All right, you're on the last one. And if you decided to do this one, it's because you needed a little extra or you just wanted to be thorough. Either way, I'm glad you're with me. The first thing we want to do is make sure that we keep change flip. So I'm going to keep the first fraction. It's kind of long to write, but it's whatever. And we're going to change this to a multiply. We're going to flip this over. Now, when you go to flip this one, this is really 2n plus 6 over 1. So when I take the reciprocal, the 1 has to be on the top and the 2n plus 6 has to be on the bottom. Okay? From there, we have to factor. And this is a special factoring case. And the reason why it's special is because this has a lot going on in it. What we're going to do is we're going to factor this one twice. I'm going to factor it above itself the first time in a different color. And then I'm going to factor it again. The reason why this one gets factored twice is because there's a GCF in here. Do you see that? They all have a multiple of 2. And when I take a GCF out, that really simplifies things. So I'm going to take a 2 out first, and that's going to leave me with n squared minus 6n minus 27. Okay, so this is my first round of factoring. But do you see this trinomial on the inside? Oh yeah, we can do something with that. Over here on the side, I'm going to magic X this part. It's a lot easier to factor a times c when I have a 1 times negative 27. And I've got a negative 6 as my b term. And I'm looking for factors of 27 that subtract a 6, which are 9 and 3. Except when I add and I need a negative 6, I need a minus 9 and a plus 3. Notice these are n's. So I legit have, when I'm done factoring this, I'm going to do it right here. I've got a 2 on the outside from this 2. That's coming down here. Then I've got my n minus 9. And then I've got my n plus 3. So there's a lot going on in this trinomial up top. And then n plus 7 does not factor, does not have a GCF. 1 is a single, cannot factor. And this guy has a GCF of 2. That's an easy peasy one. All right, there we are. We're all factored. This one was a pain in the neck to do, but I still wanted you to see it. Now we need to stop and do exclusions. Okay, so we have factored everything. Now we write our exclusions down. Exclusions are anywhere in the denominator where your fraction would be equal to 0 and the numerator of your second fraction. In this case, our numerator doesn't have one. But this case here, our denominator, n cannot be negative 7. And this one, n cannot be negative 3. I don't really need to worry about the 2. It's more the variable part. That's why I say factor first, because it's easier to find them. You could set this binomial equal to 0 and solve. You'll still get negative 3, but it's just easier to pick out when it's factored first. So our exclusions are done. Now we can reduce. So I've got n plus 3 and n plus 3. And I've got a 2 on the outside here and a 2 on the outside over here. So I'm going to reduce those 2's because they're both singles and on the outside. But there's nothing else we can reduce. See this n minus 9? There's no identical n minus 9 on the bottom. And there's no identical n plus 7 on the top. So we pretty much are done. We have 1 times n minus 9 times 1 times 1. N plus 7 times 1 times 1. And this is my solution. And these are my exclusions. I hope I helped you out today. Please feel free to contact your teacher if you have questions, and you can move on to your homework assignment.